Welcome to the second YouTube video from C&L Workshop. Today's topic is my CNC table, mounting my machine to the table, and finally my automatic tool changer rack. I first settled on a tabletop construction method. I chose a torsion box for its strength, stability, and most importantly flatness. It helps that I already had a functional base from my previous journeyman setup. After removing the top, this is what I had. As you can see, it's made out of pine, mostly 2x6 material, pocket holes screwed and glued together. The box is just over 4 feet by 4 feet. I wanted to use a standard 4 foot by 4 foot panel for the bottom. A tip here is to get straight material that will stay straight. I buy from the big box stores like most people, 2x8 to 2x12 material. I then let it sit for about 2 to 3 weeks to dry out. As it dries out, the wood warps, twists, dances around, you know the drill basically. I then lay out what is basically select grade material from my stack of dried lumber. It is definitely random lengths and widths and sometimes thicknesses. All this is to make sure I don't end up with a pretzel underneath for a table. Another consideration for using wood versus metal for my table was machine vibration. Wood is what's known as a viscoelastic material, a material that can dissipate vibrations. A search of the web led me to Montauk Hardwood Bikes. This guy makes bicycles out of ash wood. This is from his Why Ride Wood webpage. It gives you a fair amount of information about why wood is a good material for a bike. I think it's a good one for a table also. I really couldn't improve upon his explanation, so let me just reference his material. To actually design my tabletop, I used a 3D CAD package called FreeCAD. FreeCAD is in fact free to use both personally and commercially. One could also use Fusion 360 for this purpose, but FreeCAD suits me a bit better, particularly when it comes to the license. If folks are interested, I can share the drawings. They're not complete, but were enough for me to get the project done. One of my big concerns with the table was that I wanted no part of the Foreman hanging off the table. My shop is small, so I will often bump into the CNC and its table. Developing large bruises is a given, but I did not want to break a motor off. To meet this goal, I settled on a 70-inch by 70-inch basic platform with a 3-inch thickness. Remember, I already had a base much larger than 3 inches, and I need a ladder to reach the top of the table. I have always been drawn to dovetails and such, so I included a cutout section to accommodate holding material vertically. That notch was 37 inches by 12 inches. A number of tables I reviewed had this feature, but the implementation Jay Bates did seemed to suit my application best. My construction material for the top was 4x8 sheets of 3/4 inch Baltic birch-like material. By my calculations, I would need 3 sheets. Well, I was wrong, sort of. If I recall correctly, 3 or 4 of my smaller ribs are actually made of small material chunks butt jointed together when they were installed. This is not really that bad because when assembled, those ribs are glued to both top and bottom, so they'll carry the load just fine. So 3 sheets was the correct amount. I think the sheets came to about $200 total. Having laid the offsets needed for the tabletop to my base, I started to construct a support frame. Getting this frame right was tedious. Using a 4-foot level, I first leveled the base. Yes, I know the level is not the same thing as flat, but it worked for me. Once the base was level, I jointed the top of my table support pieces and attached one. Joining my support top gave me a flat surface. I installed the first piece, went in about 1/4 inch higher than the base. I did this so an uneven base would not affect my top. This first support was leveled in and attached. Now it was more about being flat than level. For my home shop, the most long flat thing I own is that 4-foot level. Needless to say, it got quite a workout. With the table support built and being reasonably happy with it, it was time to make the bottom of the table. At 70 inches, this was going to require a butt glue up of 2 plywood panels. Not usually an easy task. Fortunately, I have a Festool domino, a thank you to my wife. I think I used about 6 dominoes on the butt joint. You could have used biscuits as well. This is all about surface alignment. I created some jointed 8-foot clamping claws, again striving for flat. Then I glued up the first panel and said a prayer. Now it was time to assemble the ribs onto the bottom of the table. Lots of clamps and lots of glue and lots of time. I tried to use jointed caul clamps as much as possible, again striving to keep things flat. Things were going pretty well until it came time to glue up the top. This is where I got a little excited about clamping cauls. You can see the 2x4 clamp extenders. It seems I went a bit strong in my clamping force and introduced a bit of bow onto the top. A walk of shame involved making a relief cut on the top surface and then using through pocket screws to pull most of the bow out of the torsion box. All of this effort left me with a table that had about a 0.025 inch flatness variance when measured with the 4-foot level and feeler gauges. Yes, I slid the level all over the surface, parallel to X and Y, then at 45s and 30s, pretty much just rotating it around the entire surface looking for low spots. That pretty much finished the top work surface. I wanted to make this machine self-contained, which means mounting the control box to the wooden frame. For now, I will skip that conversation, but if you're interested, I'll cover that in another video. My wife is an electrical engineer, and she had some strong concerns about the panel installation. As you can see, the Foreman does in fact sit on top of the table as intended. As you walk by, you'll hit the tabletop before you hit the machine. The exception, of course, is if the console is swung out to the side, you're certainly going to bump into it. At this stage, and granted it's still kind of early, an extra 4 inches or 74 by 74 inches might feel better. But I do have a small shop, so 70 by 70 is just fine. What I found after heaving this beast onto the table is the Y gantry does not have much clearance as it moves through its operating range. This just made me feel uneasy. I really didn't want it to bind. So I bought some 1/8 inch aluminum bar stock and slid them underneath the pads at the corners of the machine. I do not have Herculean strength. I used an airbag type inflatable jack. When flat, the bag is less than 1/4 inch. Inflated, it goes to about 2 inches. Working alone, this let me slip it underneath the weight tubes and jack it up about 1/4 inch. At this stage, I was able to slip the shims into place, drop it back down, and move to the next corner. All of this without putting too much twist in the frame, at least that's what I believe. With the machine mounted to the table and operational, I now had to consider the spoil board. Previously, I had a QCW frame on my Journeyman, and while it worked well enough, I kind of felt like I was missing out. If you know about the Z20 gantry in the Foreman, you know you have to use 2 pieces of 3/4 inch material to get a comfortable cutting zone. I've always wanted what I heard called a pallet system. Something where I could have fixtures, vices, or even a big old flat surface mounted to a pallet that gets installed in the machine. Yes, I might have to tram the pallets in, but that's part of what a decent machinist would do anyways. And the flexibility, well, that's just priceless. Considering what I knew, I decided my approach would be to machine a grid of round pockets into my previously pristine torsion box. Yes, a little panic ensued. I put a lot of work into that baby torsion box. My grid was going to be 6 inches by 6 inches. I think that would give me enough clamping flexibility. Into these holes I was going to put screw-on T-nuts. I chose the screw-on T-nuts because, well, frankly, threaded inserts for me have always gone in kind of crooked and just never really happy with it all. If you recall a moment ago, I said there were issues with Z-height travel, as in it can't reach the bottom. This is where things get a bit janky. I used a Spec Tools 5/16 4-inch long bit with a standard ISO 30 tool holder to get maximum reach. This bit was intended for aluminum, but you go to war with the army you have. The bit did not quite make it through the entire top thickness, but it was close enough to let me finish the hole. The big factor for me was having that flat, recessed pocket to slip the T-nut into. Remember, I'll be dropping a bolt in through the top, I'll want a through hole so I don't need to worry about the bolt length. I've machined in all the pockets, but for now only installed about half the screw-on T-nut. For the pallets, my approach has been pretty simple so far. I can really be pretty crude with a piece that actually sits on the table. I make the holes for the bolts just a little bit oversized, which makes for easier insertion and some wiggle room for when clamping the fixture down. The actual spoil board then has pockets in it on top that go through a light 1/2 inch, followed by the hole for the screw. I prefer coming in from the top because as I surface I can see how close I'm coming to the screw head. When I start getting nervous, I unscrew the top spoil board and install a new one. Overall, this has worked out really well so far. So to summarize, the basic process is now: set the pallet on the table, line the 2 holes, putting in 2 bolts, snugging it down. If alignment with machine axis is required, chuck a dial indicator into the spindle and align as you would a vise, tramming the jig. Add as many bolts as needed to the remaining locations to hold it quite firmly and surface the spoil board, taking off about 20 thou each time. With the basic table system in place, I'll move on to my tool rack for the ATC. This is where I started to run into issues. My spindle uses an ISO 30 tool holder, which can use an ER32 collet. The overall length of this assembly, the tool holder, the bit, all of that good stuff, was really going to cause some clearance problems. A bit of a side note here. Why didn't I just go with an ISO 20 with an ER20 tool holder? For me, this decision was simply about stiffness. I found a graduate thesis paper in mechanical engineering that states that 15 to 20% of the bit deflection is due to the spindle tool holder interface. So basically, this is a case of bigger is better. Using this thinking, a Cat 40 tool holder is even better than my ISO 30. But now we're talking about another level of machine completely. Back to the situation at hand. How to get more space in the Z-axis. Alex at CNC Depot has found what I've come to call a shorty ISO 30 tool holder. Now this tool holder only supports an ER20 collet, but it gains me about an inch in tool clearance. An ER20 collet allows me to use a bit shank up to about 1/2, but that should be just fine. My preference for larger shank diameters go back to the whole stiffness argument. Now with this solution, it should be pointed out that these tool holders are not cheap. You have to remember these are a small run item and don't have the cost benefit of large run imported tool holders. The upcoming version of the Masso controller, version 5.1, will support the assignment of tool locations. So an individual tool can rest in the tool rack or it can be fed by hand. What this means for me is that the tools I use the most go into shorty tool holders and live in the rack, while tools I use less get fed by hand. Think huge surfacing bits and such for that sort of work. I have a small 1-inch surfacer in the rack and I think that'll just do fine. The interesting part though is going to be that what do each of these tools do to earn their spot in that rack? Once again, circling back to the tool rack. I bought and tried traditional tool forks. They had their drawbacks. They took up a lot of space or required actuators to move them into the work area and back out of it. Nick came up with a very nice design for what I'm calling a tool cup. These cups screw down to the table and interlock together. Nick's cups also have a spring action to them, which seems like it could only help when loading and unloading tools. My setup is using a 4-inch dust boot that I bought from Nick. I mentioned this dust boot because clearance during a tool change is a thing. You see people adding actuators to move the dust boot up and out of the way. Other approaches are to actually have the dust boot on magnets and have it removed and then put it back on again. That was a lot of stuff to go wrong in my mind, so I just really worried about clearance. I opted to go for a 10 tool holder rack that was basically 2 rows of 5 tools. I should point out that bit projection is potentially an issue here. Remember, a tool in the back row must clear a tool in the front row to load and unload. I usually try to keep my tool lengths to about 1.5 inches, though I could probably go to 2 inches. Why did I settle on 10? It seemed like a good compromise, how much space on the table I was willing to give up versus how many tools I wanted to store. The dimension of my rack ended up being 10 inches by 23 inches. This gives me roughly a 2-foot wide space for tiling, so I can actually slide a part in from the front and keep it going out the back. I have a dream of making custom molding. On the other hand, I still have an area of about 36 by 48 for my pallet machining. So this is working out pretty well. By the way, this is Rev 3 of my tool rack. Just saying. Well, that pretty much describes my table and how I intend to use it. Will things change as I use it? Absolutely. I hope what I've pointed out during this video is that these machines are not toasters. By that I mean you don't just drop material in and press a button, wait 3 minutes, and out pops a finished product. There's a lot of work and a lot of mistakes along the way. There will continue to be compromises and many curse words, but you will be able to do some amazing things. I've heard and watched many stories of frustration, disappointment that have ended up leading to abandonment. Buying good quality gear is very important, but I think what's even more important is the cooperation and support of the vendor that you bought these items from. Each situation seems to be unique. If there is interest, I will continue to make videos. Possible topics include my control box and electrical needs, the air compressor and drying rack. Anytime you throw an ATC into the mix, you get to play with those, dust collection and cable management, and frankly my little gotcha block, and how I'm learning what I can do with the machine on a very simple test product. We do lots of learning from that. Thank you very much for your time.